Hey everyone, and welcome to section 6.7 on polynomial equations. So basically this is pretty much the whole reason that we spent all that time learning to factor, is because we want to be able to solve polynomial equations. So let's go over what that is. Although I'm sure you can probably guess, a polynomial equation is an equation that is given by a polynomial. And the degree of that equation is the same as the degree when the polynomial is expressed in that form up there. In particular, we have polynomials of degree 1 that are called linear equations, which we already did plenty of. And what we're going to be focusing more on is polynomial equations of degree 2. These are called quadratic equations. So quadratic equations look like ax squared plus bx plus c equals 0. That's kind of familiar looking to us at this point. So next up, we're going to look at something that's kind of fundamental as far as mathematics is concerned, but it's going to be really helpful for us for solving polynomial equations, and that is the zero product property. This says that if two numbers multiply to give you 0, then either a is equal to 0 or b is equal to 0. So in other words, this means that there's no pair of numbers that are both not 0 that multiply to give you 0, which would be a kind of weird phenomenon, right? This is something we kind of take for granted, but it's worth mentioning because it's applications of this property that allow us to solve some quadratic equations. Let's look at, for example, this guy here, 5x minus 2 times the quantity 6x minus 1. So here we have two factors being multiplied to give us 0. What this means is that if either of these two quantities is equal to 0, then the entire product is equal to 0. So to solve this equation, which is, remember, finding a value of x to make it true, I am going to set both of these individual equations equal to 0. And once we have those, they're pretty easy to solve. We already know how to solve linear equations. So that x is equal to 2 over 5 or 1 over 6. So that means if x is either of these two values, then one of those factors in that product on the left-hand side is going to be 0, which means the whole thing is 0. So these are the values that you can substitute for x to get a true statement for the equation. Okay, another example, we have 4p plus 3 and 4p minus 3. Right, so p is equal to either negative 3 over 4 or 3 over 4. So that was kind of a nice situation, right? Because those quadratic equations were already nicely factored. What if we come into an equation that looks a lot uglier? So coming to this point in your math career is like one of those iconic milestones, if you will. It doesn't really get too much more mathy than solving quadratic equations. So one of the most reliable ways that we're going to be solving quadratic equations is by factoring them. Now, it doesn't work 100% of the time, but it is reasonably effective, I would say. So first we want to make sure that the quadratic equation is in the form ax squared plus bx plus c equals 0. That means you might have to move some stuff around on both sides of the equation to get it to look like that. Next, what we're going to do is factor that quadratic expression on the left-hand side using all of the factoring tricks we talked about throughout this chapter. And once we've factored it completely, we're going to use the zero product property to get to linear equations, which we're, aces at solving by now. We solve the linear equations, we can get possibly 0, 1, or 2 answers. So we're going to solve these equations, and then we're going to check the answers. All right, here we have two quadratic equations, and we want to solve them. So we're starting out kind of mild, and we'll work our way up to spicy. So I need to get my quadratic equations to look like they're supposed to, which means I want to get everything basically on one side of the equation, and then the other side equals 0. So for this first guy, I'm going to subtract 49 from both sides. So that I have 169t squared minus 49 is equal to 0. And let's see, now I want to factor that. I don't have any common factors. However, I recognize that 169 is 13 squared, and 49 is 7 squared. Difference of two squares. And now we have factored our equation. We factored the quadratic. Let's get our linear equations. So here, t is either equal to 7 over 13 or negative 7 over 13. And hey, we need to do just a real quick check. So the positive solution checks out, and since the only variable is a squared, it doesn't really matter if we put the negative one in there either. So this is also checking the negative solution. All right, now here, you might feel a very strong urge to just straight away do something like this. But I'm telling you that's bad. Okay, don't do that. Be in deep trouble if you do that. Remember that the quadratic equation has to be of the form quadratic expression on the left-hand side and 0 on the right-hand side, or vice versa. To do that, we need to move the 3x over to the left-hand side. And now my expression's not factored anymore, so I'm going to need to redo the factoring bit, which means I got to FOIL. And then I still have that minus 3x at the end there. By collecting like terms, I get 3x squared minus 14x plus 8 equals 0. Now I can use this AC method that we talked about because we got a trinomial and the coefficient of the squared term is not 1. So let's see, I need now two numbers, m and n, so that m times n is equal to 3, so it's AC, right? 3 times 8, which is equal to 24. And furthermore, I want m plus n. So since the last number is positive and the middle number is negative, both of these guys have to be negative. I want them to add up to 14. So factors of 24, let's see, 1 and 24, 2 and 12. Oh, there we have it. 2 and 12 add up to 14. So here we go. We got 3x squared minus 2x minus 12x plus 8 equals 0. Then we're going to factor by grouping. So there's one group and another group. So the first group, what does it have in common? Just an x, looks like. So we have 3x minus 2. And how about the second? Looks like there's a 4 in common. We want to factor out that negative because we want the sign on the x term to be positive, which would give us 3x minus 2. All right, and there we go. So we have 3x minus 2 times x minus 4 is equal to is equal to 0. All right, now I can solve my equation. So using the zero product property, I get that one of my solutions is 2 over 3. And the other solution is 4. So x is equal to 2 over 3 and 4. And I'm going to leave it to you to check these two answers. Please let me know if I made a mistake, because it's definitely possible. Alrighty, some more examples here. So first up, with this equation on the left here, I need to get everything over on one side. So I'll have 3x squared minus 12x minus 63 is equal to 0. I'm going to have to use the AC method again. So I need two numbers that multiply to give me... Oh, actually, we don't need to do that quite yet, because I can see that there is a common factor. The greatest common factor here is 3. Now we want to factor x squared minus 4x minus 21. So now I need m and n to equal, m times n needs to equal 21. The middle sign is negative, as well as the last sign. So I need to also have that the absolute value of m minus n is equal to 4. What are the factors of 21? 1 and 21. 3 and 7. Oh, that works. 7 minus 3 is 4. Let's see. Since the middle sign is negative, I know that the number with a larger absolute value gets the negative sign. Now we have two equations. So let's solve them using the zero product property. This 3 here is not contributing anything. There's no variable on it, so it's not going to come into play at all. And we have that x is equal to negative 3 and 7. Again, I'll leave it to you to check this set of solutions. Next, we have this creature. Do I have any common factors? There's a 3 I can factor out. Helps me somewhat, but I still have my coefficient of my squared term not equal to 1. So I'm going to use that AC business again. So I want m times n to equal 20 times 2, which is 40. And all the signs are positive, so they need to add up to 41. Well, 1 and 40 add up to 41 and multiply to give me 40. So that's got to be what it is. So now I have 3 times 20b squared plus b plus 40b plus 2 equals 0. I'm going to factor by grouping. Let's see, for the first group, what do they have in common? They have a b. How about the second group? So let's ignore this 3 here for a second. This is going to factor to b plus 2 times 20b plus 1 equals 0. We can throw the 3 back on there. But again, it doesn't have a variable. It's not doing anything. So if we wanted to, we could get rid of it by dividing both sides of the equation by 3. And it wouldn't change anything. And we really could have done that at any point. Okay, now I got two equations. So b plus 2 equals 0. This one's easy to solve. B equals -2. Then we have 20b plus 1 equals 0. So I subtract 1, and I get that b is equal to -1 over 20. B is equal to, and again, take some time to check your answers when you solve quadratic equations. These videos are already long enough, so I'm not going to do it here, but please go ahead and fact check me. That's my whole spiel about quadratic equations. And from there, the next natural stepping point would be looking at quadratic functions. So remember, a set of ordered pairs defines a relation, and sometimes that defines a function when you don't repeat an x value. So we have quadratic function equations. We can consider the function f of x equals x squared minus 2x. We can consider the function f of x equals x squared minus 2x minus 8. And we want to find two things. First, we want to find when f is equal to 7. When is f equal to 7? In this case, I would have to set x squared minus 2x minus 8 equal to 7. And from there, it's a, run-of-the-mill quadratic equation. So if I get everything on one side, I would have x squared minus 2x minus 15. Okay, now I need two numbers that multiply to give me 15, and all the signs are negative, so they gotta subtract to give me 2. 5 and 3, that will work. We have x and 5, and we have x and 3. Since it's negative, the larger absolute value gets the negative sign. So actually, it hits height 7 both when x equals 5 and when x is equal to 3. So you can take kind of the easy way out for this second part. We know f of x is equal to 7 when x is equal to 5 and when x is equal to -3. So these are 2 points that are on the graph of f. All right, something kind of similar. We want to find when f of x is equal to 0. So that means we take our equation and we set it equal to 0. Surprise, surprise. Okay, so now let's see. I want mn to be equal to 3 times 8 is 24. And let's see, so the last sign is negative, which means they're different signs. So their difference has to be equal to 10 in absolute value. So let's think about the factors of 24. We have 1 and 24, 2 and 12. 12 minus 2 is 10. Okay, so we can do that. X squared. And that sign is positive, so the guy with the larger absolute value is going to be positive. Factor by grouping. Okay, I've got two equations. Let's solve them. So x is equal to 2 over 3 and -4. Now we want to find the x-intercepts in the graph of f. Let's think back a little bit. What happens when I'm looking at an x-intercept? That's the value of x at which y is equal to 0. Since y is given by the function, this actually means we're setting our function equal to 0. And we just did that. So x is equal to 2/3 and 4. Finally, we want to find the y-intercepts, and of course that's when x is equal to 0. That one's a little bit easier because you can just replace x with 0. Right. So those are our answers. And we call values of x where the function is equal to 0 zeros of a function, which is, you know, a reasonable name. That about wraps it up for factoring. So we're done with chapter 6, moving on to chapter 7, in which we're going to start talking about rational functions. So if you liked polynomials, you might like fractions of polynomials. I don't know. Stay tuned.